All right, let's jump right into this explainer. Look, we hear a ton about artificial intelligence everywhere we go these days. But how do you, as a 10th grade developer, actually go from spotting a massive, real-world crisis to building and deploying an app that actually solves it? Well, today, we're going to give you the exact toolkit you need to build world-changing AI.
To really wrap our heads around how this works, you have to meet the villain of our story, the pink bollworm. Now, this is a microscopic pest, but it is literally devastating the livelihoods of 6 million Indian cotton farmers. And the worst part? These farmers mostly lack advanced detection tools, so it's basically impossible to protect their crops before the damage is already done. We are talking about a massive, complex crisis that threatens entire communities.
But here is your ultimate weapon against this exact kind of crisis, the AI project cycle. Instead of looking at this overwhelming agricultural disaster, panicking, and getting completely lost, this framework takes the problem and chops it down into a super efficient, modular master plan. So here's our blueprint for today's explainer. We'll cover the AI project cycle, scoping the real problem, acquiring and mapping data, exploring data visually, and finally, deploying real-world impact.
Section 1, the AI project cycle, your master blueprint.
Whenever you set up your next project, you're going to follow these 6 cyclical stages: problem scoping, data acquisition, data exploration, modeling, evaluation, and deployment. Following these ensures you systematically build and deploy a reliable AI solution without missing the crucial details. And the best part is that it's modular. So if your AI doesn't work perfectly on the first try, and hey, we're coders, we know that happens all the time, you don't have to scrap the whole thing. You just loop back to the stage that needs a little tweaking.
Section 2. Scoping the real problem, defining the crisis.
Okay, before you write a single line of code, you absolutely have to make sure you're solving a real-world issue, right? You don't want to just build a cool piece of software that nobody actually needs. We do this using the 4Ws problem canvas. Think of it like your investigative toolkit. It breaks down exactly who is hurting, those are your stakeholders, what the exact nature of the problem is, along with the evidence, where it happens, which gives you the context, and finally, why an ideal solution actually matters and brings value to society.
So watch what happens when we apply the 4 Ws to our cotton farmer crisis. An abstract idea instantly transforms into a crystal clear project goal. Who is hurting? The farmers. What is the issue? Cotton crops infected with the pink bollworm. Where is this happening? Right on the crops in the fields. And why solve it? Well, to create an AI app that nails the exact timing for pesticides, which ultimately increases their crop production and, of course, their profits.
Section 3. Acquiring and mapping data, arming the AI.
Now that our goal is locked in, we have to arm our system with reliable, authentic facts to actually fight this bollworm. But before we collect that data, there's a vital concept we need to clear up. You have training data. That's the past data you feed into the machine to teach it pattern recognition. And then you have testing data, the new data set you use later to see if the machine can actually predict future outcomes. It is absolutely critical that the authentic training data you collect is kept completely separate from the testing data. Otherwise, your AI is just cheating. It's like giving it the answers to memorize before the final exam.
So, to train your model effectively, you got to source accurate data. We're talking farm sizes, historical pesticide usage, detailed insect photos, the whole shebang. You can pull this info through web scraping, sensors, open-source government portals, or even just digital cameras. Just keep in mind, your data has to be totally authentic and accurate if you want your model to actually work out there in the real world.
Now, once you have all that data, you can't just blindly dump it into a computer. You need to draw a system map. This helps you understand the complex, real-world feedback loops connecting all your different data points. Basically, a system map visually tracks how specific elements cause changes in one another.
Think about a system you already know inside and out from science class, the water cycle. You can map out cause and effect there using simple arrows. A plus sign means a direct relationship, so if X increases, Y increases. A minus sign means an inverse relationship. If X increases, Y decreases. It's really that simple, but you absolutely have to grasp these relationships in your data before building your model.
Section 4. Exploring data visually, finding the story.
All right, before we start throwing complex algorithms around, we have to explore our data visually to find the hidden narrative inside it. Look at it this way. If you pick up a book in a library, you don't immediately read every single page to see if you like it, right? No, you skim the back cover. Data is exactly the same. We visualize it because quickly spotting an infestation trend on a chart is just significantly easier than staring at massive spreadsheets full of complex, raw numbers.
By grabbing tools like scatter plots, bar charts, or line graphs, you're essentially creating a magnifying glass for your data. You can instantly spot exactly when and where the pest populations are spiking. It tells the story clearly and makes it super easy to decide what type of AI model you actually need to build next.
Section 5. Deploying Real-World Impact, the Cotton Ace app.
Okay, so after using all those previous stages to select, model, and rigorously test your algorithms, it's finally time. You get to unleash your solution into the real world. In our case study here, the final deployment is the Cotton Ace app, and the workflow is incredible. A farmer just sets up a trap, snaps a picture of the captured pests on their phone, and uploads it. Boom. The AI steps in, uses computer vision to instantly detect the specific insect, and analyzes how bad the infestation is.
From there, the app directly guides the farmer's next moves. It tells them the exact right amount of pesticides to use, the perfect time to spray, warns them about future infestations, and can even help them seek professional help. It completely ensures they aren't wasting expensive chemicals, all while perfectly timing their defensive sprays to save their crops. It's a game changer.
And let's talk about the real-world impact. 26.5%. Let that number sink in for a second. That staggering figure is the actual profit margin jump that small farms experienced when using this AI app in the field. Plus, it came with a massive 38% drop in their pesticide costs. That right there, that is the true power of this framework.
So as an up-and-coming developer, you aren't just sitting around learning abstract concepts. You now have the exact blueprint to build something that literally changes lives, increases sustainability, and tackles massive global issues right from your laptop. So the only question left for you today is, what problem is your first AI project going to solve?